In part 2 of Where Are We Going, we have two goals. First, we want to constrain the direction of motion of our solar system even better than we did in part 1. Second, we want to take a much more micro-scale look at where we are in the galaxy, what sort of environment we are in, and what sort of environment lies ahead. This second part is premised on the fact that the galactic arms are not merely peppered with stars, but with gases and dust and cloudy regions that present an entirely non-homogeneous microscale structure to the arms of the galaxy. We see this is likely to be true of many galaxies, and indeed resembles the larger scale cosmic web as well. But let's step back first and see an updated version of the graphic from part 1, this time with the astrospheres noted. Here, the mistake we highlighted in part 1 is greatly illuminated. All the astrospheres point at the galactic center off to the right, not just our own, and it's those magnetic shields aligned with the galactic center. None of the stars is moving towards the galactic center. In fact, their trajectories are much closer to the sun's as we all go through the galaxy together. It turns out that one NASA scientist was annoyed with this general ambiguity a few years ago and posted this image online. It is not showing much different from the previous image, except that he went ahead and labeled the star at which we are heading, and it's Altair. You remember Altair.
Quiet, please. I am analyzing.
Yes, that one. And if you don't know where it is, the big clue is that I was circling it in this portion of the video from part 1. Altair completes the Aquila constellation's head and the southern end of the Summer Triangle with the Cygnus constellation and Vega and Lyra. Yesterday's direction field guess circle is now annotated with the position of Altair. We can sufficiently consider the direction of motion corrected and understood. Now, back to the arm of the galaxy. There is a massive void in local space known as the local bubble, the remnant shell of numerous supernovae, with the core remaining as the local interstellar cloud through which we are indeed currently moving. Now, while the supernova void is tremendously sparse, its neutral helium content is the primary source of the X-ray background of the sky, and the local cloud here at the core around our sun is 6 times more dense in hydrogen and is confirmed to be strongly magnetized. It also has a wide array of other elements as well. We are in a supernova remnant after all, and we should consider the oxygen to neon ratios relatively similar to other sources to be a pretty good indicator of the general elemental abundances. It is expressly believed by some at NASA that there is even more oxygen there locked up in the rocks and dust of the cloud, like iron oxide or aluminum oxide, as is much of the oxygen inside of our Earth, which is the mantle's most abundant element, by the way, just in rock form, not the gas we are used to breathing. It is interesting to note that it was the same interstellar or galactic wind that originally misguided some to believe we were heading towards the center of the galaxy that eventually showed our position. It was based on that galactic wind that they published this alongside the cloud image, the chart showing how the older results hinted at our being in the void amidst the empty areas of the interstellar cloud, but how newer data, based on that galactic wind, caused us to now know that we are indeed inside of the local cloud. But that is about to change. You see, while the sun has been on a steady trajectory, the cloud is moving in another direction, to the left. So the sun is more likely to have entered the cloud at where the red arrow is pointing, that portion of the cloud there, but did so many years ago when that portion of the cloud was back over to the right, such that the red and yellow arrows would have been on top of one another. This combined relative motion analysis means we are moving pretty much directly into an empty area within some of the remaining nova core clouds, out of the denser magnetized shroud cocooning our solar system, and literally into the void. In part 3, we will examine what this might mean for the future of our solar system and our planet.